American astronauts stranded in space, their lives on the line.
The Lunar module was designed to only support 2 people. I keep counting the crew, there's 3 of us.
Houston, we've had a problem.
And it was that time when I said, it's going to be tough, maybe impossible to get this crew back home.
An extraordinary rescue effort to bring them home safely. A combination of human courage and advanced technology. Now, Apollo 13 on Modern Marvels.
Guidance release, 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13.
April 11th, 1970. Apollo 13 takes to the heavens. The thunder of the Saturn V rocket's 5 F1 engines generating 160 million horsepower. To shoot for the moon requires raw power. The Saturn V rocket is 363 feet tall, 60 feet higher than the Statue of Liberty, including its pedestal, and weighs 13 times as much as the statue itself. Lifted into Earth orbit at 17,500 miles per hour is the mission's 3-man crew. Commander James Lovell, Lunar Module Pilot Fred Hayes, and Command Module Pilot John Swigert. Apollo 13 would be the first mission to make a difficult lunar landing in rugged terrain. Back in 1969, Apollo 11 made history in the Sea of Tranquility. The first lunar landing, a moonwalk by Neil Armstrong and Edwin Aldrin Jr. Apollo 12 featured 2 more moonwalks, this time in the ocean of storms. Both missions, however, touched down on relatively flat portions of the lunar surface. Apollo 13 was to land in the mountainous region of the Fra Mauro Highlands, whose rocky surface scientists believed held clues to the birth of not only the moon, but of the entire solar system.
Here on the Earth, we don't have any of that original rock. And the reason is because all the erosion techniques that are happening every day on this planet. And so this was a chance to get in and see if we could find some of that original primordial rock.
Apollo 13 was going to be my last flight. I thought this would be a great accumulation of a space flight career. So I was looking very anxiously to land in the Highlands, which had not been done before.
12 minutes and 39 seconds into the flight, Apollo 13 is inserted into Earth orbit. Back at Mission Control in Houston, Apollo 13 is in the capable hands of Flight Director Gene Kranz. The square-jawed ex-Korean War aviator is known for his unshakable sense of organization and command.
The flight director's job description is incredibly simple. It says, the flight director may take any action needed for crew safety and mission success.
Early in the mission, Kranz faced several minor glitches. An engine failure in the second stage booster raised concerns about the fuel supply. And even before that, an 11th hour personnel change sent ripples of insecurity through Mission Control. 1 week earlier, the crew was exposed to German measles, and doctors found Ken Mattingly, the designated command module pilot, had never had the measles before, and therefore was not immune.
When you've worked on something, it's been your goal for many years, and you've worked on this particular flight for over a year, and there isn't a long line of repeat opportunities. I had a good case of feeling sorry for myself.
I didn't want to lose him, and I argued with the doctors, saying that, I can't think of a better place to have the measles than around the moon. However, the doctors did agree, and he was dropped, and we brought Jack Swigert, the backup command module pilot, on board.
Superbly trained for the job, Swigert fit in well. 2 hours, 41 minutes, and 47 seconds after launch, the spacecraft is injected into a lunar trajectory at 24,500 miles per hour. A half hour later, the cylindrical service module and conical command module are separated from the third stage booster, turned around in space, and then moved back in for docking with the lunar module. Lunar touchdown is scheduled for April 15th, 4 days away. But then, a simple request for equipment maintenance changes everything. Oxygen and hydrogen are kept on board in a supercooled state, minus 340 degrees Fahrenheit. When mixed in the ship's fuel cells, the gases combine to form electricity, heat, and even drinking water. Because oxygen and hydrogen in this supercooled state tend to settle unevenly in the tanks, the crew is periodically asked to stir the tanks with a remotely operated electric fan. Engineers refer to this as a cryostir. It falls to the Electrical and Environmental Command Officer, or ECOM, to request the procedure.
Dane, we've got one more item for you when you get a chance. We'd like it to stir up your cryo tanks. In addition, I have a shaft and trunnion.
Just to be a good ECOM, I decided to have an extra stir done before they went to sleep, which was about an hour before the end of my shift. We had a few things we had to clean up before they went to bed, and so I asked the flight director if we could add to the list, how about a stir?
2 days, 7 hours, and 54 minutes into the mission, Jack Swigert flips the fan switch to stir the tanks.
We couldn't tell that they did it except by watching the gauges, and all of a sudden there was nothing there. The data went away, and I looked at my screen and I said, "Uh-oh."
As Liebergot's troubling oxygen tank readings ripple through the monitoring equipment at Mission Control. In space, the astronauts grapple with a ship that is out of control. 16 seconds after Swigert flipped the fan switch, an explosive bang and shudder rocked Apollo 13.
We had a pretty large bang associated with the caution and warning now.
Lights coming on, noise all over, jets trying to fire to stabilize the spacecraft. We didn't know what happened.
We will not lose this crew. Don't ever consider it, because if you even let that move in the smallest fashion into your mind, you're going to start compromising the direction you need to make the right things happen. So think positive, make things happen.
Maybe most wonderful.
For the first 60 seconds, the voice loops were literally chaotic because so many reports were coming in as the controllers would see jets firing and they'd see the electrical problem progress through other elements of the system.
On board Apollo 13, there is a loss of power in what is called Main Bus B, one of two main power distribution panels. If one is gone, it means that half the systems in the spacecraft are dead. As in all space travel, adequate electrical power is critical. Without it, all vital systems aboard Apollo 13 would go dark, transforming the most advanced spacecraft in the world into a metal hulk aimlessly drifting in space, without navigation or life support systems.
I knew it was something very serious, something not normal, very wrong, because there were a very large number of caution and warning lights on. The caution and warning light array has two color lights. Some are red, which generally means very bad, and some are orange or yellow, which means bad but not quite so bad. And if I recall, we had about 7 of those lights on, plus a master alarm, a big red light, plus a blue computer restart light. This did not replicate anything I'd ever encountered in training for a single failure.
And Houston, we had a restart on our computer. We had pink light and the restart reset.
Roger, restart. And reset on the reset.
We had never ever simulated a case like this because you don't simulate up to a quadruple failure. He may simulate a double failure, but not this kind of cascading quadruple failure, because there's nothing to work. I mean, the spacecraft dies and into simulation.
In the meantime, Jack Swigert has called Mission Control.
Okay, Houston, we've had a problem here. Can say again, please. Houston, we've had a problem.
You get that sort of burning sensation in the stomach, and you're saying, why me? Why now? Why didn't it happen on 12 or wait to 14? And what do we do to get out of this thing? Then it dawned on me that we are in more serious trouble than merely not landing on the moon. And that's when our thought process changed from being one of disappointment to one of survival.
Relying on his pilot's instincts, Commander Lovell eyeballs the situation. He looks out the window and doesn't like what he sees.
We are venting something out into space.
Roger, we copy your venting.
The gas of some sort.
Jim Lovell called down from the spacecraft. Hey, I'm looking outside window 5 in the spacecraft. I see some kind of a gaseous substance, some kind of a vapor. I think we may be venting our oxygen. And this was the final piece of information that said, hey, we had an explosion on board the spacecraft with a lot of collateral damage. And now this is not a mission that's going to go to the moon. This is a mission of survival. And it was that time when I looked into the eyes of the Tiger and said, it's going to be tough, maybe impossible to get this crew back home.
The engines of the Saturn V must burn more than 5.8 million pounds of propellant in order to accelerate to 24,500 miles per hour, the speed required to put a spacecraft on a path toward the moon. Apollo 13 will continue on Modern Marvels. We now return to Apollo 13 on Modern Marvels. 2 days, 8 hours, 33 minutes into the mission. Apollo 13 is stranded in space. Those on the ground and up above can't help but think of the darkest chapter in NASA's recent past. In 1967, during the first Apollo mission, an explosive fire instantly killed all 3 men aboard. Virgil Gus Grissom, Edward White, and Roger Chaffee lost their lives on the launch pad when a fire broke out inside the cabin and spread rapidly in the concentrated oxygen environment.
In January of 1967, we had the horrendous Apollo 1 fire, and I think it was a prime year to demonstrate what happens when you push for a goal so hard that you become blind, in some ways complacent to the dangers. Thousands of changes were made to the Apollo spacecraft, and I think a lot of people consider today that those 3 guys did not give their lives in vain.
The Apollo Command Module, one of the most complex spacecraft ever built, would undergo many modifications and safety checks before Americans again traveled in space. Apollo 7, carrying 3 astronauts, flight tested the command module circling the Earth. Apollo 8, with James Lovell aboard as command module pilot, was the first lunar orbital mission. The world was awed by the crew's stunning images of the moon and our own small blue planet, and moved by their readings from the Bible's book of Genesis.
God said, let the waters under the heaven be gathered together into one place, and let the dry land appear, and it was so. And God called the dry land earth. And God saw that it was good. And from the crew of Apollo 8, God bless all of you on the good earth.
Apollo 9 was a dry run for the lunar module, the engineering miracle which would eventually allow astronauts to touch down on the moon.
Okay, we're nice and stable with respect to you. It's a nice looking machine. So is yours.
Apollo 10 again went to the moon, this time for an orbital run-through. It was followed by the twin triumphs of Apollo 11 and 12. Apollo 13 mission was thwarted before it got to the moon. Its service module is useless. Half its electrical systems, called Electrical Bus B, are dead. The command module, the only part of the spacecraft with a heat shield capable of surviving re-entry, has just 2 hours of battery power. Back at Mission Control, Flight Director Gene Kranz knows he has only one real option to bring the crew home: use the lunar module as a lifeboat.
And we have a procedure for getting power from the LEM. We'd like you to copy down.
Okay, stand by, Jack. That sounds like good news.
I made a call to the crew and I said, look, all flight controllers, settle down. Let's make your calls crisp. Electrical Bus A is still good. Don't do anything to screw it up. The lunar module's attached. We're going to use that as our lifeboat. Get me more people, get me more communications, and get me more computing capabilities. And this was what I would say the turning point in the fight to save the crew.
The concept of using the lunar module as a lifeboat was explored on earlier missions and run in simulations. The operations team envisioned using the lunar module's thrusters to correct a faulty moon orbit, for example. But working the lifeboat plan between the Earth and the Moon brought on a new set of problems that no one had ever considered.
The lunar module was designed never to come back home again, had no heat shield. The skin was so thin that you could punch your fist right through it if you wanted to. And more than that, the lunar module was designed to only support 2 people. And, you know, I keep counting the crew, there's 3 of us.
2 days, 9 hours, 37 minutes into the mission, the Apollo 13 crew leaves the command service module and takes refuge in the lunar module. To save fuel and electricity, Mission Control opts for what is called a free return trajectory. Lovell and his crew could fly around the dark side of the moon and hopefully use that body's gravitational force to slingshot them homeward. It is a risky plan because it depends upon precise navigation using sightings on stars, and that was going to be difficult because the explosion had created yet another problem for Apollo 13.
When I looked out the window, the explosion had put around the spacecraft thousands of small pieces of debris, and these were false stars. We couldn't tell a real star from a false star. There was no way to do a star sighting to know whether our platform had been aligned correctly or not.
We're moving 7 miles a second toward the moon. And this debris cloud actually is moving along with us. And until we perform a maneuver to get away from that debris, it's going to be with us.
Mission Control's solution was to use the only celestial bodies visible to the crew and attempt to set a course by them.
They found features on the sun, the Earth, and the moon that could be easily recognized by the crew and could be essentially established as a point source, so that we could use this as the equivalent of a star.
As Lovell sights the Earth, Hayes sights the moon through a periscope-like device called the Alignment Optical Telescope. If the alignment is good, the Earth and the moon line up in the sights, verifying that the navigational system is on target.
And slowly but surely, it was almost like the music from My Fair Lady. You know, I think I've got it, and then pretty soon, the last puff of the rocket engine and the spacecraft stopped, and the fine alignment on the telescope showed that we were pointing at the sun, and so we said, "Hey, we're okay."
2 days, 13 hours, and 29 minutes into the mission, the crew fires the lunar module descent engine to begin the free return flight path. Running the ship on reduced power means the living conditions are difficult. The temperature inside the lunar module, or LEM, is dropping and soon reaches 38 degrees Fahrenheit, about as cold as a refrigerator.
Water was collecting everywhere, and on every electric connector, a big glob of water was building up. After a day, all three of us huddled in the LEM, which in a way, I guess, helped just mutual body warmth.
As the astronauts shiver in space amid their damp and dripping consoles, the equipment aboard Apollo 13, ironically, is in danger of overheating. Normally, water mixed with a coolant called glycol is circulated through the spacecraft to keep the equipment functioning properly. But on Apollo 13, water is scarce because 2 of the 3 fuel cells that produce it are damaged beyond repair. Heat will build up quickly in the spacecraft's electrical systems. Mission Control's only solution is to shut down all but the most critical devices.
Get the spacecraft powered down as rapidly as we can to a survival mode, save the energy in case we might need it downstream, and this is going to put us on a plateau where we can think.
Though he keeps a cool head, Kranz desperately needs to know how long the electrical power in the spacecraft could last. The news from his engineers is not good. To make it back to Earth, the astronaut's lifeboat would have to consume only 15 amps of electricity per hour. But the lunar module designers calculate the minimum draw at 20 amps per hour. Somehow, Kranz and his team have to get the draw down by 5 amps to make it possible for the crew of Apollo 13 to get home. While the launch controllers get out their slide rules and grapple with the problem around the clock, Kranz knows that even that will not be enough. Although the mainframe systems used by NASA were state-of-the-art in 1970, by today's standards they are cumbersome and agonizingly slow, with less computing power than today's average laptop.
You had very little flexibility in using these machines. That's the bad news, but the good news was it was a massive leap forward from the very primitive systems that we used in the early Mercury and the Gemini systems.
The astronauts of Apollo 13 have occupied their wounded ship for 3 days. As the computers run the numbers, Kranz's team runs on pure adrenaline, surviving on catnaps, working equations, trying to reconstruct why the explosion occurred and what can be done to fix it before it's too late. The Apollo guidance computer is approximately the same size as today's desktop computer, but had as much as 100 times less computing capacity. Apollo 13 will continue on Modern Marvels. We now return to Apollo 13 on Modern Marvels. At the time of the Apollo 13 mission, many Americans had become somewhat complacent about spaceflight. But with word of trouble in space, the mission becomes big news. People everywhere are glued to their televisions for the latest bulletin. Newspapers carry banner headlines. Never before has a NASA failure been paraded around the world so nakedly and for so long. Spaceflight is also difficult for those left behind, the astronauts' loved ones and families. Surviving on whatever news NASA lets out, they want to know if their husbands, fathers, and friends are all right, and what their chances are of making it back alive. Marilyn Lovell, wife of Commander James Lovell, must contend with hordes of reporters knocking on her door with questions that she can't answer.
Are they going to get home? Are they going to hit the Earth? Are they going to miss the Earth? Are they getting poisoned? You know, are they going to run out of oxygen? All these things sort of grow on the families.
It's a much worse situation for those on the ground with their expectations of hearing that you've made it through, because literally they are helpless to be able to do anything during that period.
In space, the men of Apollo 13 could only watch the blue marble of the Earth drift away and imagine what might have been had they made their mark on the gray mystery drifting by below them, like the others who were there first. During Apollo 13's silent transit around the backside of the moon, the astronauts are out of contact with Earth tracking stations for 24 minutes and 35 seconds. Emerging on the other side, lunar gravitational force redirects their trajectory homeward.
Mr. Krantz, can you tell us what sort of physical discomfort the crew is in at the moment?
We're trying to work up some kind of a crew rest cycle right now to give them all an adequate amount of rest between now and the possible mid-course correction at 104 hours.
While those on the ground watch and worry, they cannot guess how the cold and damp conditions inside the lunar module take their toll on the crew. Fred Haise is the first victim, falling ill with a bladder infection.
I didn't realize it at first. He tried to keep it quiet for a while, but pretty soon his teeth started chattering, and he was getting quite sick.
Probably caused by the climate, severe cold, getting tired. We didn't drink enough water, but that combination of things allowed this bug to pick me out as the weakest one of the three.
As Fred Haise's condition gets worse, there is another crisis growing in intensity. The Apollo 13 crew is at risk of poisoning themselves with every breath.
One of the things that had to be contended with was the carbon dioxide buildup in the spacecraft from the crew expiration of their breath. And yes, it was anticipated to become a problem.
With each breath in, the crew draws precious oxygen into their lungs. With each breath out, they expel carbon dioxide, a deadly substance in sufficient quantity. Normally, the waste carbon dioxide is removed by passing it through lithium hydroxide crystals, packed in cylindrical canisters. But the onboard supply of those canisters is running dangerously low.
A group of engineers recognized that we would eventually run out of these cylindrical canisters that we use to clean the carbon dioxide out of the air. But they also recognized we had plenty of square canisters over in the command and service module that weren't going to get used.
We literally had square pegs and round holes. The different contractor built the system in the command module, used little cubical lithium hydroxide canisters, and because of design considerations in the lunar module, they made them cylindrical.
So they came up with the idea of fabricating an adapter made out of the cardboard cover of the flight plan, the plastic bag that they had their lunar suits in. We used a sock as a filter, and then some duct tape and a hose, and we fashioned this adapter and tested it in the laboratories. And then the engineers actually brought it in mission control so we could see what it looked like. Then we wrote the procedures, now that we knew what it looked like, on how told the crew how to make this device.
Shaking their heads with amusement and using a lot of duct tape, the crew constructs a makeshift air purifier with the odd assortment of parts dictated by mission control.
But it worked perfectly. As soon as we had it in place and had the air flowing through this jury-rig canister, we saw that the partial pressure of carbon dioxide started to decrease.
The jury-rigged adapter buys the crew more time, yet their most difficult challenges lay ahead. As their cold, dark spacecraft rapidly approaches Earth at 7,212 miles per hour, back on the ground, flight controllers are laboring to come up with a way to bring the ship's electrical systems back online and bring Apollo 13 back to life without causing irreparable damage to the lifeboat, the crew's only hope. The electrical system aboard Apollo 13's command module contains about 15 miles of wire, enough to wire 50 two-bedroom homes. Apollo 13 will return on Modern Marvels. We now return to Apollo 13 on Modern Marvels. As the astronauts of Apollo 13 drift toward home in their wounded spacecraft, they have done everything possible to conserve their resources. A free return course around the back of the moon has successfully used lunar gravity to slingshot Apollo 13 toward Earth with minimal course adjustments and fuel expenditure. But the largest problem of all remains to be solved. Does Apollo 13 have enough electrical power to get back to Earth? Gene Kranz, the flight director overseeing the mission, has his team on a round-the-clock quest to calculate how the Apollo 13 spacecraft might draw no more than 15 amps per hour.
Frankly, you just work whatever it takes to get the job done. To my recollection, I do not recall any rest for any member of my team for almost 2 days.
Answers were coming in from all over the country. A brain trust assembled by NASA. It included just about everyone who had built, worked on, or thought about the design of Apollo 13, including astronaut Ken Mattingly, who had been scrubbed from the mission.
Mattingly was more or less the troubleshooter, moving between the various teams, looking at what was happening, commenting, critiquing. Ken is the kind of guy you like to have on the team because he asks the right questions. And he also senses options and alternatives that maybe people really weren't developing.
Kranz and his team are faced with the problem of writing a procedure for something that has never been attempted. Before Apollo 13 can begin re-entry, the spacecraft systems have to be brought back online. It is a tall order. Powered down, Apollo 13 is transmitting scant data back to Houston.
In order to extend the consumables so we could coast back to the Earth, which is going to take another 100 and some odd hours, we had to take all the electrical power possible off the lunar module. And so that meant just turning off all of the guidance computers. We left ourselves with a fan to circulate cabin atmosphere, a radio to talk, and that's about it. The most disturbing thing to the folks on the ground was the fact that all this equipment turned off. They had no further insight into the health of the spacecraft.
Without active instrumentation, the launch controllers have to find a way to power up the spacecraft systems with the least amount of electrical drain. Since the lunar module is still connected to the command module, engineers pursue the most logical path. Allow the two units to share electrical resources.
It was a long, complex procedure which took people all over the country contributing to just a running series of debates and discussions about how to do it, until they finally came up with a plan which seemed to fit the power budget.
At this point, the lunar module is close to freezing. The walls and windows drip with condensed water. While the ground team labors over the plan, aboard Apollo 13, Commander James Lovell is preoccupied with one inescapable fact. The blue-green orb of the Earth is getting closer, and he hasn't received instructions from Mission Control on exactly how he will restart his spacecraft's electrical systems.
They were very slow on getting those instructions up, and I was getting very worried. I mean, we were all in a course that was going to intercept the Earth in some manner. And I knew that our people were getting very, very tired. And I tried to chastise the control center, saying, let's just get the stuff to turn this thing on and make sure we get it back home safely.
The procedure is so complex that when finally complete, it encompasses 400 entries and is 39 pages long. As Lovell pilots the spacecraft, Swigert, with assistance from Hayes, copies down the procedure by hand. No mistakes can be tolerated. A flawless execution is required for the crew to come back alive.
We were trying to voice up the procedures to the crew for the final entry that we realized how this exhaustion, the cold temperatures, and the dehydration that Fred Hayes was suffering. And yet he was the man who had to execute the procedures on board the lunar module.
It was read up to us, and we did not have blank paper. So we had to use the inside and back and front covers on checklist books and burn cards that were meant to be filled in for burns, but we used those because it was very lengthy and it all had to be handwritten.
For the power-up procedure to be successful, each man has to do his part, with Lovell guiding the ship, Hayes in the LEM, And Swigert in the command module, they all have to flip a dizzying array of switches in just the right order.
We had the lunar module that we were using as our lifeboat. We had the cone-shaped command module, which was required for reentry. It had the only heat shield, but it had a very limited electrical power lifetime. Then we had the damaged service module. We had to maneuver this stack of spacecraft into a orientation so we could separate the pieces on different trajectories.
The men of Apollo 13 have passed 5 days and 7 hours in space. It is up to this exhausted crew, who have been subsisting on 3 hours of sleep per night, to safely guide their spacecraft into the recovery zone.
We have to come inside a 2-degree pie-shaped wedge that comes down to the atmosphere. No less than 5.5 degrees, no greater than 7.5 degrees. We had to thread ourselves inside that atmosphere for a safe landing. If we come in too shallow, we skip out like skipping a stone on water. If we come in too steep, the sudden deceleration makes us a fiery meteor for a few brief seconds, and that would be it.
The timeline is getting tighter. The crew's recovery window is small, and as it happens, nature is not on their side. A typhoon is developing in the recovery area, making the odds even slimmer for the safe return of Apollo 13. When an Apollo spacecraft re-entered Earth's atmosphere, it generated enough energy to light up Los Angeles for a minute and a half. Apollo 13 will return on Modern Marvels. We now return to Apollo 13 on Modern Marvels. The entire Apollo 13 mission hangs in the balance as the crew begins the complex power-up procedure. The job is expected to take 30 minutes to complete. Even though the spacecraft is chilly and damp, thankfully, not one electrical circuit shorts out from condensation on the wires. On the ground, Mission Control watches as the spacecraft systems come back online. Command Module pilot Jack Swigert is as tired as the rest of the crew, but he faces an absolutely critical task.
Jack had the critical thing of throwing the right switch, so he got rid of the service module so he wouldn't also get rid of Fred and I on the lunar module. He taped the little thing on the lunar module jettison switch saying no, so that he wouldn't throw that one when Fred and I were in there.
Swigert throws the right switch, and the service module is detached. Despite their fatigue and Fred Hayes' high fever, the crew completes the entire procedure in just 21 minutes. The crew watches amazed as the service module drifts away in space, 39,529 miles from Earth.
And there's one whole side of that spacecraft missing. Is that right? Right by the high gate antenna, the whole panel is blown out, almost from the base to the engine. Copy that.
While the lunar module is okay, for the first time it is clear how much damage to the service module has been caused by the explosion. Back at Mission Control, there is more bad news. The spacecraft is drawing 2 more amps than it ought to. Tolerances are so tight that Apollo 13 might run short of electrical power just when it's needed most. Added to that concern is the knowledge that the spacecraft has drifted off course.
It was dicey all the way to the very end. The Navy came in and said, we have a typhoon developing in the Pacific just off Samoa, where we're bringing spacecraft back to, and they were really looking at seeing if we could change our landing point any. But that is when we determined that we were actually not on the proper return path. As we're now approaching the Earth's atmosphere, we're only about 8 hours out. The trajectory people come in and say, hey, flight, we are off our return trajectory again. We have to perform another emergency maneuver to get back in the reentry corridor.
The 2 extra amps are vanquished when at Mission Control's instruction, part of Apollo 13's backup navigation system is shut down. Finally, re-entry begins after 5 difficult days in space.
When you first hit the atmosphere, the very upper reaches, you're ionizing the air to some degree, so the spacecraft, including the interior, takes on a little white glow. Just think of yourself inside of a neon light bulb.
The ionization of air around the command module during re-entry prevents radio contact with mission control for a period of about 4 minutes. But during Apollo 13's re-entry, 5 minutes pass with no communication from the crew.
Mission control becomes absolutely silent. All you hear is the noise of the air conditioning and the hum of the electronics, and every eye is on the wall, clocks counting down to 0. When it finally hits 0, you say, Apollo 13, Houston, and you don't get any response. All you hear is static. And you call again, and you call again, and finally, after 1 minute, for the first time in this mission, you're wondering what in the hell happened. But hope is eternal there. You keep calling, and at 1 minute and 27 seconds, you got this call.
Okay, go.
Okay, we read you, Jack.
That was Command Module Pilot Jack Swigert. And when you see those parachutes blossom on that screen, I believe many of the mission controllers, myself included, literally cried.
5 days, 22 hours, and 54 minutes into the mission, the command module splashes down within 4 miles of the recovery aircraft carrier.
The splashdown comes, and of course, and we bob back up again, and we see water on the windshield. There's a great sigh of relief.
The weary and chilled astronauts board the recovery ship, USS Iwo Jima.
The chaplain then turned and he gave a prayer of thanks for the millions and millions of people who prayed for our safe return.
O Lord, we joyfully welcome back to Earth astronauts Lovell, Hayes, and Swigert. We offer our humble thanksgiving for this successful recovery. Amen.
And when that crew hit the carrier deck, and when we handed over our responsibility to the aircraft carrier task force commander, then we could celebrate. And that was only then that we could feel this intense release that we had pulled off a miracle.
When the astronauts are reunited with their families in Hawaii, President Richard Nixon awards them the Presidential Medal of Freedom. And the world rejoices at the crew's safe return.
Well, it was sort of hard to grasp all this positive attention we were getting. The one letter that I cherish, Charles Lindbergh wrote me that he was in the Philippines, but listened to the radio from Manila to how far we were coming and whether we were going to make it or not.
Lindbergh, like the astronauts of Apollo 13, knew about staring down fear and overcoming the limitations of a flying machine.
Apollo 13, mission-wise, was a failure. But it was a triumph in human ability to take a crisis and through crisis management get almost certain catastrophe back home safely.
A triumph of ingenuity and guts. The Apollo 13 mission is often called NASA's most successful failure. It caused the American Space Agency to re-examine itself and the purpose of the space program. In a mission post-mortem, engineers learned that excess voltage fed to the oxygen tank a month before launch had damaged a thermostat, causing the tank to overheat and degrading the insulation on the electrical wiring. When the fan was turned on for the cryostir, a short circuit resulted in a spark, which caused the tank to catch fire and explode. The lessons learned on the Apollo 13 mission will remain with NASA forever and bring a deeper meaning to the grand mission of going to the moon.
For some, it has been seen as an act of necessity.